Bacteria are everywhere. Did you know there are more bacteria cells in you than there are human cells in you? We tend to see bacteria as our biggest enemies, but yet they are also our biggest allies. Microorganisms are so numerous and endlessly adaptable that we will never be able to control them completely. In the past decades, we have come to understand microorganisms better, and it convinced human beings to believe that by using biocides, antibiotics and pesticides, we might be able to get a control over them. However, this has resulted in the exact opposite. Bacteria and viruses developed further and adapted, making them resistant to our control attempts and technologies, creating resistant superbugs and hard-to-control funguses and viruses. Parx Materials is determined to break this vicious cycle. Take a look at a contaminated surface. Bacteria adhere to the surface to take up nutrients and to proliferate. Traditional biocides biologically or chemically interact with these bacteria, for example, killing them by puncturing their cell membrane. Effective and lethal, but also triggering the bacteria's response to build up resistance, making them stronger. Our bio-inspired technology allows us to create hygienic surfaces, reducing the presence of bacteria and viruses by 99% and higher, but by an ecological and biodiversity safe method, copied from the human immune system. Surfaces made with Parx technology show physical barrier properties, preventing the latching on or attachment of bacteria and viruses, keeping the germs at bay. We found that the attachment is the critical first step for microorganisms to last and be able to proliferate. Without latching on, germs follow their normal life cycle, but without proliferation. This is resulting in effective performance, reducing the risk of infection, cross-contamination or spread. We are able to generate non-stick formulations for microorganisms and integrate them in roughly any type of polymer. For this, we avoid using any chemical or biological technology and focus purely on polymer surface physics. For example, employing van der Waals forces to affect bacteria and biofilm adhesion. The theory is simple and effective, minimizing the possibility of bacteria and viruses to adhere to a surface, which is critical for them to persist, without being hostile towards them and without the possibility of building up a resistance. We effectively control colonization by bacteria and viruses by preventing adhesion and biofilm formation without using biocides.